Welcome to the Deep Dive, where you send us your sources and we unpack them to get to the core of what you need to know. Have you ever been absolutely certain of a memory only to find out later it wasn't quite right? Or maybe it never happened at all? Today, we're diving into something really fundamental to who we are, yet surprisingly fragile: our memory. Our mission is to explore why our recollections can be so unreliable, how our brains can sometimes create experiences that never actually occurred, and what the latest science tells us about the intricate brain processes behind it all. It's a journey into the fascinating and sometimes, unsettling landscape of how we remember.
And we're drawing from a really rich collection of sources today. We've got cognitive psychology, neuroscience research, discussions on memory in forensic settings, everyday life. What's truly fascinating here is how these different perspectives all seem to converge. They paint this clear picture. Memory isn't a perfect recording, not at all. It's an active, reconstructive process, constantly rebuilding.
Okay, let's unpack this then. First stop, understanding the fundamental ways our memories can fail us. It's not always about, a perfect system just breaking down, is it? It seems more complex.
Precisely. Our memories can falter. Well, not just because information wasn't properly encoded or stored in the first place, but also because we simply can't accurately retrieve what is actually there. Think of your memory like a vast, complex library. It's a good analogy, I think. Some books might be poorly cataloged right from the start. Others get misplaced entirely. And sometimes, even when a book is right there on the shelf, it might just be incredibly hard to find.
Right, the retrieval fails. And it goes beyond just simple forgetting, doesn't it? Our brains are incredibly efficient using things like social categories and schemas. We all kind of know about schemas, those mental shortcuts or frameworks. They help us organize new information. But how do these powerful tools sometimes, betray our memory?
Yes, schemas are incredibly efficient, no doubt about that. They allow us to quickly make sense of the world, fill in gaps in our knowledge almost automatically. But this efficiency is really a double-edged sword. While they help us remember things that fit the pattern, they can also lead us to confidently recall things that never actually happened just because they fit our mental blueprint, or to distort and misremember actual events so they align better with our expectations.
Okay, so if our basic recall is shaped like that, what does this mean for our everyday judgments, how we interpret the world around us?
That raises a really important question, because beyond just recall, a whole variety of cognitive biases also significantly influence the accuracy of our judgments. Take confirmation bias, for instance. We all do it. We unconsciously favor information that just aligns with what we already believe. Or the halo effect, where our overall positive impression of someone impacts how we perceive their character or even their actions. And another critical one is the misinformation effect. This is where new information introduced after an event can subtly interfere with the original memory. It makes eyewitness accounts incredibly fragile, actually.
Okay, that's where it gets truly wild for me. It's one thing to forget a detail or even, distort one slightly. But what about remembering something that never happened? Remembering it with vivid detail, absolute conviction. How is that distinct from just a simple error?
Right, it's a huge difference. False memory isn't just a simple mistake or a blurred detail. It involves this profound level of certitude, this belief in the validity of a memory that is entirely fabricated. It's about distinctly and confidently recalling an event that, in reality, just did not occur. It's fundamentally different.
That's fascinating. Can you give us some concrete examples? How are these false memories formed in, say, controlled settings?
Certainly. One really well-researched phenomenon is the misinformation effect. Elizabeth Loftus pioneered a lot of this work, a classic study by Loftus and Palmer. They showed that simply changing a single verb in a question about a car accident, like asking if cars smashed into each other versus hit each other.
Just one word.
Just one word. It dramatically influenced how fast participants estimated the cars were going. And even more striking, later on, people who were exposed to a question containing a false presupposition, something like, "Did you see a barn?" when there was no barn.
Okay. Leading question.
Exactly. They were far more likely to later claim they did see a barn, even though it wasn't in the original footage at all. It vividly highlights how even a small piece of new information can subtly distort our original memory.
Wow. It's unsettling to think language itself can literally change what we think we saw.
Yeah.
But what about implanting something even bigger, an entire event, a whole experience that never happened? How do scientists even, begin to do that ethically?
Well, that's the event implantation paradigm. It's quite something. In these studies, researchers, often with the help of a participant's relative, providing plausible details. They introduce a plausible yet entirely false event from childhood, say, getting lost in a shopping mall. They present this alongside several true childhood memories.
Okay.
Then, through repeated questioning, sometimes using guided imagery, about 15% of adults, and actually a surprising 25% of children, will come to remember the false event, often in vivid detail.
15 to 25%, just from suggestion.
Yes. And if more suggestive techniques are used, like really encouraging mental imagery, those figures can jump significantly, over 35% for adults and maybe even 60% for children. And here's the crucial part. Once they construct and explain this false event, they genuinely believe it happened. They often can't tell it apart from their real memories. They're unable to realize it didn't happen.
That is truly mind-bending. It really makes you question, well, everything you think you remember from childhood, doesn't it? What about suggestibility more broadly, especially when it comes to something as sensitive as a child's memory?
Suggestibility plays a huge and often quite concerning role. Both children and adults can be persuaded of past acts, sometimes even criminal ones, unfortunately. Now, while adults might be influenced perhaps by certain kinds of suggestive therapies, children are particularly vulnerable. They can form these false memories from repeated leading questions, even unintentional ones. Studies have consistently shown that suggestion leads to more errors in memory performance. It's quite clear.
So even well-meaning questions could cause harm.
Potentially, yes. Careless or repetitive questions from, well-meaning parents, teachers, or even doctors, especially with young children, they can inadvertently contaminate a child's statement. This can happen even before any official investigation begins.
And our own imagination. That can play tricks too. I mean, I can certainly relate to imagining something so vividly I almost believe it happened.
Absolutely. Our own minds can be culprits. Counterfactual imagination, just thinking what if, can actively distort memory. Studies show that simply rehearsing and imagining a fabricated alibi for a mock crime, like really picturing yourself somewhere else, it can make it harder to detect the original true memory of the crime in subsequent memory tests.
Really? Just imagining it?
Yes. For instance, participants who learned and imagined a fake alibi immediately after a mock crime, or even practiced imagining it for a week, they showed reduced detection of their original crime memory compared to those who didn't practice an alibi. And interestingly, the more vividly participants rated their imagined actions, the more likely they were to later misreport those imagined actions as things they truly performed.
So imagination blurs the lines. What about something deliberate, like lying? Does intentionally fabricating something, telling a lie, also impact our own recall later?
It does seem to. Research suggests that the act of lying itself can lead to memory impairments. Liars might forget what they've falsely denied. And perhaps even more surprisingly, they can sometimes form false memories about lies they haven't actually told yet. Like, anticipating a lie makes it feel real.
Wow.
The thinking is that this is due to the cognitive resources, the brain power, that's consumed by the complex strategies required for deception. It takes effort to lie consistently.
Okay, this leads us straight to the brain itself then. If memory isn't just about accessing a perfect file, what is happening in our brains when we remember or when we misremember? Our sources talk about the subjective experience of memory, that feeling of remembering.
Right. The subjective experience of autobiographical memory, remembering events from our own lives, feeling that sense of reliving them. That's something scientists have only really been able to study rigorously fairly recently. It's challenging, obviously. Because traditional self-reports, diaries, they're susceptible to all the reconstructive errors and biases we've just discussed. But the breakthroughs in neuroscience are giving us some really insightful clues.
So what brain regions are involved in this incredibly complex reconstructive process? And how, if at all, do they distinguish a true memory from a false one? Is there a clear signal?
Well, what's really insightful here is understanding that remembering isn't like playing back a video file at all. It's an active construction. It engages this whole orchestra of brain regions, especially what's often called the posterior medial system. This is an extensive network. It includes the hippocampus, the parahippocampal cortex, and others like the retrosplenial cortex, lateral parietal cortex.
A whole network.
A whole network. And it's crucial for that subjective feeling of remembering, for reconstructing those vivid, cohesive, multimodal event. Features the sights, the sounds, the feelings. Your hippocampus acts kind of like this central conductor, bringing all these different elements together.
Okay, so within that network, are there specific areas with really distinct roles?
Yeah, definitely. The angular gyrus, for example, it seems highly sensitive to multimodal information integrating sight, sound, touch. It played a key role in making our memories feel rich and multisensory. Its activity actually correlates pretty strongly with how vivid and precise a memory feels to us.
And what about checking if it's real?
Well, then there's the prefrontal cortex, PFC. Think of it as your brain's reality checker. It's critical for what psychologists call reality monitoring. So distinguishing between what you actually did, like, did I really lock the door, versus what you only imagined doing, or maybe just thought about doing.
Right.
When that system kind of fumbles, that's when you might confidently search for your keys in a spot you only thought about putting them. It blurs the line between thought and action.
That makes sense. So if we can pinpoint these areas, what about the actual neural signatures, the specific brain activity patterns? Can they differentiate a true memory from a false one? Can we see a clear distinction?
This is a really active and honestly pretty complex area of research right now. Scientists use tools like event-related potentials, ERPs, to peek inside the brain's immediate electrical chatter, sort of moment-by-moment activity.
Okay.
And they have found certain unique brain whispers, you could say, like something called a late parietal component, or LPC. It's often more positive, more pronounced for true memories compared to misleading ones, which suggests maybe more active recollection is happening.
So there are some differences.
There are some differences found in some studies, yes, but the results aren't always definitive across all studies, and sometimes researchers find no significant differences for certain ERP components between suggested false memories and true memories. It's not perfectly clear-cut.
Okay, so if ERPs give us these fleeting electrical signals, can we actually see these brain regions at work, maybe with fMRI? And if so, do those images show a definitive difference between a true memory and a completely fabricated one?
Neuroimaging studies using fMRI or PEEK scans have definitely shown both intriguing similarities and differences. True memories seem consistently linked to activity back in the sensory cortex.
Like replaying the senses.
Exactly. It makes sense, right? It reflects the brain reactivating the original sights, sounds, feelings of the actual event. For instance, the left temporoparietal cortex, which is associated with auditory processing, it shows greater activation during true recognition of words someone actually heard compared to false recognition of words they didn't.
Okay.
But what's also notable is that both true and false memory formation often involve regions in the prefrontal cortex, that reality monitoring area we mentioned too,
Yeah.
and also the medial temporal lobe, MTL, which includes the hippocampus and parahippocampal gyrus, key memory areas.
Those similar areas involved for both, but maybe different patterns. But I'm gathering here that drawing really clear, definitive conclusions is tricky business, even with these advanced tools.
That's exactly right. The sheer variation and complexity of all the cognitive processes involved, it makes it incredibly difficult to establish clear, consistent differences between true and false memories just by looking at brain activity. And it's really important to remember, neuroimaging data are correlational, not causal.
Right. It shows activity, not necessarily why.
Precisely. We see what's active, but we can't definitively say that particular pattern of activity caused the memory to be true or false, or is a guaranteed sign of one or the other. There's a significant ongoing debate in the field about how to interpret observed brain activation, what cognitive processes it really represents. So finding a direct brain signature that definitively tells a true memory from a false one with perfect accuracy, that's proving very difficult.
Okay, this raises a really critical question then. If our memories and even our brain's ability to verify them are so fallible, what are the profound implications? Especially in really high-stakes environments, like the courtroom.
It's a huge issue. The inability to reliably discriminate between true and false memories is a significant ongoing problem in forensic psychology. Eyewitness memory, which is often treated as crucial evidence, can be profoundly altered by subsequent information or beliefs. And tragically, this has led to wrongful convictions in many documented cases.
But we've certainly seen some intense debate around figures like Elizabeth Loftus and this whole concept of recovered memories. How should we, as informed listeners, kind of think about that highly charged period, the memory wars?
The memory wars of the 1990s. Yes.
Yep.
It's centered on a really heated debate. Could traumatic memories truly be repressed? pushed out of awareness and then later recovered, often through therapy, versus the alternative view, where these actually false memories, perhaps unintentionally suggested by therapists. Elizabeth Loftus, whose groundbreaking work, as we discussed, demonstrates how false events can be implanted, she's been a key figure. She has at times been highly paid to testify against individuals claiming recovered memories in court. And some judges have rejected her theories in specific cases, while others find her work vital for understanding memory's fragility. It's complex, but what's fascinating and often overlooked in the debate is that the vast majority of documented recovered memories of trauma actually occur outside of therapeutic contexts. Often, they happen spontaneously, triggered by something in the environment.
So it's not a simple case of one extreme or the other. It's not all false, not all repressed and recovered.
Exactly. That's crucial to understand. Not all recovered memories are false. And really, no credible memory specialist believes every recovered memory of trauma is necessarily fabricated. That's a straw man. The validity depends heavily on the specific context of recovery. How did the memory surface? Was there suggestion involved? It's plausible that traumatic experiences that weren't fully processed or understood at the time might be less accessible later on, but they could genuinely be retrieved later, perhaps through automatic processing of environmental cues, things that trigger the memory network. However, it's also really important not to confuse this with other different phenomena. Things like just everyday forgetfulness, or choosing not to disclose something, non-disclosure, or childhood amnesia, the natural inability most of us have to recall events before age 3, or even conscious suppression, where you actively try not to think about something traumatic. Those are all different from the specific debated concept of repression.
That's a really important set of distinctions. And what about false confessions? How does memory's fallibility play into that terrifying scenario?
High levels of suggestibility, which we've talked about, and also, to a lesser extent, compliance, just going along with authority figures. These can significantly elevate the risk for false confessions. People can come to believe they did something they didn't. While experimental studies in the lab consistently show this link, real-world field studies actually demonstrate varying degrees of this effect. It suggests it's a complex interaction of personality, situation, interrogation techniques, many factors.
Okay. And thinking about trying to detect deception or hidden knowledge forensically, what really stands out to you about the limitations of memory detection tests? Things like the implicit association test or the concealed information test. Are they reliable?
Well, these tests aim to detect concealed information, often by measuring physiological responses like heart rate or skin conductance or implicit reaction times. However, studies show they are vulnerable to countermeasures.
People can cheat them.
Potentially, yes. For instance, rehearsing a false alibi, as we discussed earlier, with counterfactual imagination that can effectively distort test results, make the fake feel familiar. It's also vital to acknowledge that laboratory mock crimes, where most of these tests are developed, they differ significantly from real criminal memories, especially in terms of the emotional content, the fear, the adrenaline, and also the intense motivation to beat the test in a real-world high-stakes scenario.
Right, the stakes are much lower in the lab.
Exactly. And all of that impacts the vividness and durability of memories. Emotional arousal, for instance, can lead to something called memory narrowing, where the central details of an event, the really emotional core, might be remembered very well, maybe even enhanced, but the peripheral details, what someone was wearing, the color of the walls, those might be poorly encoded or forgotten. Tests might pick up weird results because of that.
That makes sense. So beyond these high-stakes legal cases, our everyday memory has its quirks too, right?
Yeah.
What are some common memory lapses that adults typically experience that really highlight this reconstructive, imperfect nature we've been discussing?
Oh, definitely. Many of us experience these daily memory lapses all the time. Those frustrating tip-of-the-tongue moments where you know the word but can't quite grab it, forgetting what you just read, like moments after looking away from the page.
Happens to me all the time.
Me too. Or getting briefly lost on a really familiar journey. Like, how did I end up here? Starting a task, walking into a room, and completely forgetting while you went in there?
The classic.
The classic. Or just forgetting an appointment you knew you had. Interestingly, research shows retrospective memory lapses, forgetting past events, those are reported more frequently by older adults. But younger adults tend to report more prospective lapses, forgetting to do something in the future, like mailing a letter or picking something up.
Huh. Interesting difference.
Yeah. And it's also worth noting that when people report on their memory, their subjective memory reports, they're often influenced more by their general self-schemas. I have a good memory, or my memory is getting worse with age, and by stereotypes about aging, rather than specific recollections of actual memory failures. That is, unless the questions are really carefully formatted to elicit those concrete, specific examples, otherwise we tend to generalize.
Right. So our beliefs about our memory affect how we report it. This whole deep dive has really shown us, I think, that our memories are definitely not faithful recordings of the past, not like a camera. Instead, they're dynamic, they're constantly reconstructed, and they're surprisingly vulnerable to distortion, to suggestion, and even just to our own imagination running wild. There's a pretty profound shift in how we might think about ourselves and our past.
Absolutely. And if we connect this to the bigger picture, it absolutely underscores the critical importance of critical thinking, always. When it comes to any memory, whether it's our own most cherished personal recollections, or maybe a friend's dramatic anecdote, or especially in high-stakes legal contexts, knowledge of these intricate brain processes, these cognitive vulnerabilities, it's not just fascinating, it's really essential for navigating the world.
So what does this all mean for you listening right now? Knowing that your own memories might not be as perfectly preserved, as accurate as you once thought. Consider how this reconstructive nature of memory might influence not just how you view something like eyewitness testimony, but also how you approach your own personal recollections, the stories you tell yourself about your life, and even the collective stories we tell about our past as a society. How reliable are those? How might understanding memory's inherent imperfections empower us, maybe, to be more empathetic with others when their memories differ from ours? Or perhaps even more vigilant, more discerning in our daily lives about the information we accept and the memories we form? It's definitely a lot to think about.